Logging off from fucking Twitch, I set up my channels to be content. Like fucking content. YouTube content. And if I were to stream, it's just more content. I don't know what these sociopaths on Twitch are all about. Some sexual, deranged fucking fantasies. Delusions, reality, sex games, 24/7, 24/7. I don't understand. Maybe they just had sex in real life and then they go on Twitch. That happens a lot too. These people are fucked up. They're fucked up. Like, I'm a little engineer. This video is about science and mathematics. And I got my folder here with my engineering mathematics. Now, when I do the work, I make the science. I do the hypothesis, I do the research, I do the theory. I build the product. And I make a fucking videos. And in the videos, I share my interests. Whether I not have a bitch. I haven't had a bitch since 2014. And that was for 1 week or 2 weeks. 1 week. 2 weeks. 2 weeks. 2 weeks I had a bitch in 2014. And since 2015, more than 10 years, I've been making content. No bitches. Not a single bitch. Absolutely no bitches. 10 years making content. And these people are streaming, whether they got 3 viewers or 3,000 viewers, they are sociopath sexual deviants. Sociopath sexual deviants. All on Twitch. And I'm just trying to get some entertainment. I'm just trying to watch some games, trying to watch some music, trying to watch some documentaries, chatting, science, whatever I can find. But no, just what's wrong with them? What's wrong with them? And they're millionaires. And they're fucking millionaires because you just look at their subs, 3,000 subscriptions, 4,000 subscriptions, 7,000 subscriptions. It costs $12 a subscription. Say $10 and $10 US a subscription. Twitch takes 30%, but say they take half. That's $5 per subscription you get. You got 4,000 subscriptions. Each month, $5. That's $20,000 a month. $20,000 a month from just 4,000 subscriptions. And then they get donations. They get like $4,000 a stream. And they stream 30 days a week. So that's another 3,000 times 30. That's $80,000. They're making $100K a month. $100K a month they're making. $100K a month. And they're still sexual deviants. They're making $100K a month to be sexually deranged psychopaths. Sexually deranged psychopaths pulling in $100K a month. Whereas I'm an engineer, I'm a university student, I'm a cook, I'm an athlete, I'm a musician. I can't get a bitch and I can't get $100K a month. And they can fuck any transvestite they want with $100,000 per month. With no education, no talents, no musical skills, rarely gaming skills, no athletics, no cooking skills, like just a fucking sexual sociopath pulling in $100K a month. And all I'm about is content. Gaming, music, education, engineering, mathematics, science. Acting. Just content. Traditional content. Or what the fuck are we talking about? Traditional content. I'm so confused. I always thought YouTube, you need to share talent. That's the point of YouTube. What the hell are we talking about? YouTube, you gotta share talent. If your talent is to go outside and cause fucking debauchery, That's your talent. Be a Logan Paul. Be a Jake Paul. But why the fuck you gotta make hardcore sex tapes and make that your content? Why can't you just be a traditional Logan Jake Paul? Go outside and fucking dance to a song. Go outside and dance to a song. What the fuck is the point of hooking up with controversial porn stars and putting that on Twitter? How the hell is that internet content? What does that have to do with internet content? How the hell is that going out and making a music video? You're having hookups with controversial sex figures from the porn industry. And that's your... What the fuck is that, bro? Anyways, back to the topic of this video. It is science and engineering and mathematics summary. Basically, fuck the documents. Basically, the first thing you got is algebra. Basic addition, subtraction, multiplication, division, percentages, which are aka fractions, which are aka decimals. That's your basic order of operations. If you can fucking walk around all day, do your budget and your expenses and your finances and your money planning and your calculations and your prices and your income and your taxes, if you calculate all that in your head on pen and paper with a calculator, with a phone, you find out addition, subtraction, multiplication, division, percentage, decimals, fractions, all right? Odds, betting odds, ratios. You got to get good at that. That comes from literal middle school and high school early years. Early years, high school, middle school. Then you got your advanced science math. You don't need to know advanced math. If you know that shit, that's what you gotta know. The advanced math is like calculus, derivatives, integration, exponentials, algebra, equations, and trigonometry. Why trigonometry? You got triangles. All the angles add up to 180 degrees. Right angle is 90 degrees. Sine, cos, tangent. And trigonometry is the basis of all engineering, because when you graph the function of a sinusoid and a cosine, they are waves. They're waves. Infinite duration waves. They got a wavelength, they got an amplitude, and they got a frequency. And that is how waves travel in real life. Electromagnetic waves, radiation, sound waves, mechanical waves, water waves, light, gravitational waves, even electricity travels as a wave. Alternating current, AC current, is a sinusoidal wave. So if you want to get into physics, natural science, and engineering, you got to understand trigonometry, sine, and cos in terms of waves. There's a very complex way to express these sinusoidal waves, and that is as a complex exponential. That is the letter e to the power of negative square root of -1 times the frequency, right? And that's a complex way, but that's only for engineers. For the regular ass guy, all you got to know about a sinusoid and a cosine wave is it's got an amplitude and there's a middle. So you can cut the wave in half. All right? Once you cut the wave in half, this part is the amplitude. And it's the same above and below. It doesn't get distorted. It's the same above and below. So you cut the wave in half, you have an amplitude. It's the same above and below. Now where you move the middle is the offset. The offset. So usually it's at 0. When it's at 0 and you have alternating current, you go plus 5 volts, minus 5 volts. The difference of that is 10 volts. But the amplitude is not 10. The amplitude is 5. 5 and then negative 5. That's your alternating current. Now if you add a DC component, a DC is a flat line. So direct current. So say you add DC 10 volts. Now your offset is 10 volts. Plus 5, 15 volts. Negative 5, 5 volts. Now you go from plus 15 volts to 5 volts. But the amplitude is still 5. The middle is 10 volts. That's your DC offset. So you add DC and you got your AC. So you got your amplitude. Then you got the wavelength. The wavelength. What's important about wavelength? That is the physical property of the wave. So when you got electricity, when you got a light wave, when you got a UV wave, when you got a radio wave, an antenna, a microwave, these are all waves that really have that wavelength. So like a radio wave, it's like 2 meters. It's like 2 meters. So a 2 meter wavelength cannot go through a building, But you have microwaves, which are like 1 centimeter. Those can go through walls and shit, but not metal or whatever, you know? So you got your UV rays, which are like a millimeter. And those can penetrate your skin and your skin tissue cells, and that's how you get a radiation. So then you got your nuclear radiation, your alpha, beta, gamma rays, which are deadly. So you got to stay away from those because those are micrometers. And those penetrate through everything. And they bombard you. They attack your atoms, right? Your cells, your molecules. Then you got your wave in your fucking electricity wall outlet. The current in your electricity wall outlet. How do you calculate it? It's 60 hertz. That's frequency. And is frequency 1 over wavelength? I don't know. Is frequency is 1 over period. Speed is the speed of light. So then you got to know for speed of light. What's the speed of light? Is electricity, electrons, electromagnetic radiation, radio waves. All this mumbo jumbo in electromagnetics travels at the speed of light. So that's the speed of the wave. Speed of light, amplitude, wavelength, and the most important is the frequency. Frequency is 1 cycle. So you know how it repeats? It goes like this and it keeps repeating. 1 cycle. Do. That's 1 cycle. How much time is there for 1 cycle? All right? Now, that's the most important because that's related to energy. And the bigger the frequency, so the more smaller the wave, because the faster it goes, bigger frequency, smaller wavelength. The more energy of the wave. And because all of these electromagnetic waves travel at the speed of light, when you change the frequency, you're changing the wavelength. Because they all travel at the same speed, in order to have more frequency, the wavelengths have to be shorter so more oscillations can fit. So if more oscillations fit, there's bigger frequency. and the wavelength is smaller. If less oscillations fit, that's smaller frequency, bigger wavelength, and it fills out the same amount of space, all traveling at the speed of light. So you got more frequencies, smaller wavelengths, more energy, all traveling at the speed of light. And that's your natural phenomena of electromagnetics. So you got your basic multiplication, division, your trigonometry, which leads to your waves, your calculus, which is slopes of waves. So calculus is just slopes and areas of a graph. So when you have a graph, you got a function. A function is usually some kind of fucked up wave, some kind of crazy wave. And when you take a point on the wave, you want to know the slope, how quickly it's changing, accelerating or decelerating, all right? Going up or down. And that's what calculus is. That's a derivative. A derivative is always a slope. If the wave's like this point, that's a slope. And this slope tells you how fast it's changing at any specific point. So that's calculus. That's derivatives. And then you have integration, and integration is the opposite. It's the area under the graph. So when you have like a wave like this, that looks like this, integrate from here to here will tell you all the way to the axis what this area is, what this total area is. And that's integration. So area and rate of change. And why is that important numerically is because it tells you optimization. It tells you like, say you're graphing cost versus items sold. So like you did some market research and you were like, when we increase the price, we sell this many units. When we decrease the price in this country, we sell this many units. So you have some sort of data and you want to find the theoretical best point. So if you plug in a function, a graph, data, a wave, and you use calculus on it, you can find where that slope is the greatest or neutral, right? So you can find the best slope. And the point where you find that best slope is optimization. So that's your minimum and your maximum. Your minimum and your maximum. So you can find the minimum and you can find the maximum of any point along a function, graph, data, wave. So that's where calculus comes in handy. You can find rates of change, areas, and that corresponds to optimization. That's calculus. In advanced engineering mathematics, you have these complex exponentials, which are basically like just algebra. But the problem with algebra is multiplication, addition, subtraction, variables, equations, division, subtraction, multiplication, right? Square root, powers, basic order of operations with variables. So because there's variables, it's an equation. And you want to solve it. You want to figure out what this variable is, what that variable is, how they relate to each other. And you do that with these order of operations: multiplication, subtraction, addition, division, square root, power, right? And when you have in engineering, sometimes you get some fucked up terms. You get some crazy, you get sine, you get cos, you get frequencies, you get wavelengths, you get crazy ass terms. And when you want to do these operations, calculus also comes into play in algebra. So when you want to do these operations with these equations and this algebra, plus use maybe some calculus later, it becomes so fucked up. So the way we simplify it is we transform all the data. And we do that with this math, that this complex that guy invented called Euler's or Fourier or Laplace. These were the scientists that came up with these different transforms where you take the entire fucking equation, the entire function, which is an equation. You take the entire equation and you integrate it you integrate each part of the equation with some crazy ass garbage complex exponential. E to the power of square root of -1 times frequency times time times blah 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 blah. And you get, it's impossible to do it, but there's a table. So if you find sine is 1 over s, x squared, x to the power of 2 is 1 over s plus 1, something like that. So you get this crazy ass equation in engineering with your sine, cos, your alternating current, your speeds, your frequency, your wavelength. You get these crazy terms and you just want to solve the algebra, right? And then plus do calculus on it. So you want to solve the algebra, you take all the fucking terms and you find that table and you transform them all. Once you transform them all, it becomes simple math. A high school equation. You get your little s, which is like a variable. X, A, B, Z. Same thing, just s. So you get your s and polynomial, regular ass polynomial. S over 1 plus s times s squared plus s plus 5s. And you solve for at equals 7. Well, it equals like 5.672456 meters. And you solve and you find out what s is. Or you solve for a simple version of s, and then that's s though. Like what the fuck is s? Then you take the table and you do the opposite transform. So the table transforms everything into s, and then you have the reverse. So the reverse is you take all the s's and you transform them back, and you find out like your s plus 5 squared is actually 5 cosine with frequency 2 pi plus 90 degrees. And that's your answer. Y'all. Your crazy ass equation with the crazy ass shit, you transform it, you do the simple ass algebra, you transform it back, and you get cos 2 pi plus 90 degrees. That's the solution. And now you can perform your calculus and your that you want to optimize that. So that's the most complicated engineering mathematics. Calculus can be used in civil engineering, mechanical engineering, when you want to find the optimum weight, the optimum load, the optimum strength, the optimum speed, acceleration, mass. Chemical engineering, the optimum rate of reaction, amount of energy in the reaction, amount of heat, total amounts of substance needed. It's just math. So that's why I say engineering is math. It's math and science, but it's like a lot of math, because the science is easy to grasp. But to actually, because if it's just fucking science, that's a science major. That's physics, chemistry, biology, those things. But if you want engineering, it's applied science, which means you got to add math to it. And what you're doing when you're adding math to it is you're building a product. By adding math to chemistry, now you calculated how much of substance A and how much of substance B you need, and how safely, how much heat, how much energy, how quickly, and how much waste it will produce to get your product. So when you take your chemistry, which is like this plus this equals this, and you add engineering to it, you're adding math to it. And you're saying this plus this plus this, and you're doing a rate of change in your calculus, and you're finding it equals this product. Civil engineering, you're building a structure. Mechanical engineering, you're building a motion, vehicle, engine, turbine. Electrical engineering, you're producing electrical devices and generators and power and transmission lines. And that's engineering with mathematics. Now, of course, you have to know the science. So for the science, you can find that anywhere on YouTube. The properties of electromagnetics, the properties of forces, the properties of chemistry, the properties of gases, solids, liquids, metals, the elements, electrons, atoms, molecules, the fundamental forces, nuclear, gravity, electromagnetics, speed, motion, kinematics, gravity, potential energy, kinetic energy, potential energy, chemical energy, electrical energy, nuclear energy. So that's all of the science. And then with the engineering, you put math into it. And then, of course, you have your middle school and high school mathematics, which is your order of operations with some calculus. And then you have your biology, which is separate from physics and chemistry. Your biology is your medicine, the human body. Biology is like chemistry, but there's only 4 elements: carbon, oxygen, hydrogen, and in protein, nitrogen. So it's just carbon, hydrogen, and oxygen. Everything in your body is carbon, hydrogen, oxygen. Now, because your body is all protein as well, the molecules and the signals and the elements and the catalysts and the compounds, they're all proteins, and the DNA, there's nitrogen as well. So you got carbon, hydrogen, oxygen, and then nitrogen. And that's the big composition of organic species. And you got your respiratory system, your heart rate, your lungs, your brain, your nervous system, your brain synapses, your peripheral nervous system, your digestive system, your reproductive system, your organs, your liver, your pancreas, your kidneys, your intestines, your muscle fibers, your skeletal fibers, your skeleton, hair and nails and eyes and ears and nose and mouth, and then the diseases and the illnesses and the virus and the treatments and the medicines and the pills and the blood system and the imbalances and the and then lastly, you have nature. You have the climate, you have the environment, you have animals, you have plants, you have sunlight and photosynthesis, and which is how plants make food from carbon dioxide and sunlight and water. You have the cycle of life, you have natural phenomenon, you have tsunamis, earthquakes, tornadoes, hurricanes, storms, deserts, dry land, wind gusts, mountains, seas, lakes, forests. So you got your environment. That's all there is to it. You got your basic mathematics, algebra, and then your engineering, physics, and applied mathematics. Then you got your biology. You got your natural sciences, physics, chemistry, biology, medicine, and then you got your natural world, your animals, your plants, your climate. And that's all of science, mathematics, and engineering. And then you got your galaxies and your planets, which is just regular science, just at really high energies and a lot of mass. A lot of mass, a lot of energy. And then outside our galaxy, we got things we haven't discovered, like dark matter, antimatter, and dark energy. Dark energy is just the opposite of gravity, but there's a ton of it. You got dark energy, got your antimatter, and you got your dark matter. Dark matter is just matter that we can't see. But matter has mass, which creates gravity, and it has to exist, but we can't see it because it needs more mass to hold the universe together. So it exists, we just can't see it because In order for these galaxies to stay together, they need all this mass for more gravity. And that's why we say that's dark matter. We haven't discovered it. We can't see it. Light can't see it. But it exists, creating this mass for gravity and galaxies to hold. And what else can I say? What else can I say? Did I miss anything? Like, if you want your technology, your phone, your computer, your mouse, your keyboard, your headphones, your speakers, your TVs, your screens, your electrical devices, your appliances, that's all electrical engineering. That's transistors and chips and processors and CPUs and memory and storage and gigabytes and RAM. That's all electrical components. And logic gates and bits and bytes and mathematical operations and clock processors. That's all microelectronics. And if you want your vehicles, your cars, your boats, your trains, your planes, that's all mechanical engineering. The engine, the speed, the control, the braking, the acceleration, the steering, the hydraulic steering. You turn a steering wheel, you can't physically turn the fucking wheels. It's hydraulics. So your little hands have some liquid power that turns the entire vehicle. So that's your mechanical engineering. If you want your structures, you want your buildings, you want your bridges, you want your hydroelectric dams, you want your roads, you want your mines, you want your oil, that's mineral and civil engineering. And then you got your nuclear stuff, that's nuclear engineering. Chemical stuff, chemical engineering. Medicinal stuff, biology. Medical research, surgeons, labs, medical diagnosis, treatments. Then you got your health, your therapy. That's not science anymore, but there's also social sciences, which is a type of science because there's a method and a procedure and data and results and truth to it. So if there's truth to it, it's a science. So you got your social sciences, which is your therapy, your mental health, your behavioral studies, your sociology, your group studies, your ethnicities, your genders, your people, your children, your adults, your families, your relationships, society in general, and behaviors of society and tendencies of society and illnesses and virtues of society and money and poverty and climate and food and hierarchy of needs and lust and vices and temptations and faith and belief and religion and culture. So that's your social science. Whew. I did so much talking. All right, that's all the science. You got your engineering, mathematics, medicine, social science, natural world, stars and galaxies. And that was this review of science and mathematics. All right. Whew. Yeah. And I got documents for all of this stuff. Well, simple documents, but I didn't explain too much anyway, so you can find this simple explanation in the simple documents. So, tell a friend, share this video, like, subscribe, share, rate, review, comment, leave a like, thumbs up, stay classy, kick it 1 2, keep it real.